Welcome to the All-In on Tech discussions organized by Smart-EDU Hub. This is episode 2, and we're calling it AI Wins Nobel Prize in Physics, Why Physicists Won for Computer Science Breakthroughs.
Right.
We're going to be diving deep into what has to be the most talked about Nobel of 2024.
Oh, for sure. The physics award going to John Hopfield from Princeton and Geoffrey Hinton from Toronto. Foundational work for neural networks.
Exactly. And that's where the tension immediately starts.
It really is. I mean, Hopfield is a physicist, no question. His early work on polaritons is classic physics. But Geoffrey Hinton...
He's a computer scientist, a neuroscientist. The guy is basically a founding father of modern AI.
So the question everyone was asking was, why physics? And the Nobel Committee gave a very strong answer.
They did. They said modern machine learning and AI owe this huge debt to physics.
And that's our mission for this deep dive, right?
Yeah.
We're going to unpack that using an analysis written by Cattell and Vrabey to see how these lines get so blurry.
So let's start with the laureates themselves. John Hopfield was recognized for the Hopfield model. What does that actually do?
Okay, so the Hopfield model is basically a system for what we call associative memory.
Associative memory.
Yeah, think of it like this. You're trying to remember the route to a hotel you visited last year. Now, the weather's different, the traffic is new, maybe a building has changed.
Right, the data is noisy, it's imperfect.
Exactly. But your brain reconstructs the original, ideal memory from those distorted clues. The Hopfield model taught computers how to do that, how to find a known pattern, even when the input is a mess.
Okay, so Hopfield gave us the memory. Then you have Hinton, who built on that with Boltzmann machines.
Yeah.
Where does his work diverge?
So Boltzmann machines are a huge step forward because they were built for unsupervised learning.
Meaning the system teaches itself.
Precisely. It learns the patterns in data without anyone labeling them first, and then it can generate new things that fit those patterns. The name itself, Boltzmann, is a direct nod to physics. Ludwig Boltzmann and statistical mechanics.
So the link was always there, right in the name.
It was. The core concept that connects Hopfield's physics to all of this is something called the Ising model. It was a theory from the 1920s to explain magnetism.
Magnetism. You mean like the spin of an electron being either up or down?
That's the one. Hopfield's genius was seeing an analogy there. He simplified that idea down to a binary system. Forget electrons, just imagine tokens on a table that can be black or red.
Okay.
He defined a pattern he wanted the system to remember, let's say a smiley face made of these tokens, as the system's lowest energy state, its most stable point.
The stereo fundamentala.
Exactly. So when you feed the network a distorted, messy pattern, the system starts adjusting the connections between its neurons to reduce that overall energy.
And it forces itself to evolve back toward the original stable smiley face.
It's pure physics. And get this. The math needed to calculate the memory capacity of that model. It was developed by Geoffrey.
Who won the Nobel Prize for Physics in 2021.
You see, it's a direct pipeline from 20th century physics straight into modern AI.
So if that's the foundation, what was Hinton's big contribution that led us to, Gen AI and everything we see today?
Hinton's game changer was popularizing the backpropagation algorithm.
Backpropagation. It sounds complex.
The concept is actually pretty intuitive. It's essentially an error correction mechanism. When the network makes a mistake, the algorithm runs backward through all the connections
To see where it went wrong.
to see exactly how much each connection contributed to that error. It allows for these tiny surgical adjustments. It's how large language models, LLMs, learn and get better and better with every single try.
So this Nobel Prize isn't really about some fundamental particle, is it?
Not at all. It's about how ideas from physics created the most advanced assistants we have today. The biggest revolutions always happen at that intersection where disciplines collide.
And that's really the takeaway for you listening. The most advanced intelligence we have on our devices is driven by a very old physics principle, the search for stability, the idea of reducing energy. Just think about that. A concept from 19th century physics is now what lets you create entire worlds on your smartphone, something that was pure science fiction just a few months ago. That's our deep dive for today. You can find a link to the Cattell and Vrabey's article in the description below. Thank you for joining us for this All-In on Tech discussion.
Thanks, everyone.
And don't forget to like and subscribe to the Smart-EDU Hub channel. That way you'll be the first to enjoy our new deep dives.